Boys, stop guys up here. At this point, you should have your notes packet out, or you need to be quickly moving to do so. This is again the packet from before, like I talked about yesterday, that if you had it, we're going to pick up from the last lesson today. If you don't have a packet, yesterday I asked kind of around who felt like they needed one, and I have a few extra copies, but I believe in here I didn't have anyone that needed a copy for today. Is that correct? Anyone else need? You're in trouble. I won't need you to have the notes for the day. We're good? You got it? Okay. Cool. He's got it. You're good. All right. Keep listening. Your task on page 28 down at the bottom is to take a look at graphing this quadratic, which is one of the only things we didn't really review yesterday during our review. So remember, we yesterday talked about like factoring and solving for the roots or zeros, but on day, I think 1, that you guys were with me, remember we did all that stuff with like axis of symmetry and the vertex and the y-intercept and all of those things, negative b over 2a and all the things. So the goal in this do first is to try to remember some of that stuff and try to graph this function right here. That's going to be your task while I'm taking attendance. But really quickly, remember you have A, B, and C. If there's nothing here, if there's not like a third term, it's like C is 0. Okay, if you want to write that to help you, you can. So talk to your neighbors. I'm going to let you kind of work together on this, but I should hear math conversations about this problem as I'm taking attendance. Emilio? Yep. Oh, great question. Emilio, thanks for noticing. You might have noticed that mine's different than yours. Yours says plus 2x or something? Yes. Okay, I think what happened here, sorry, the plus 2x gets you some messier numbers, so I actually changed it to make it friendlier numbers, and just forgot to tell you. So let's actually all change it to minus 6x plus 0, so that we can move through this a little bit quicker later, and then we'll be good. Fitness is great, but not right now. Right now, the Bravos are great. Numbers negative b over 2a. Oh my god. No. Yes? It's your table. At first I was really confused about what you were asking. And I caught up.
I bet you've done so.
Okay, Gio, Samuel, Pedro B. Not here. Leisha, Johan, Pedro D. Not here. Kaylin, here. Carlos, here. Catherine, here. Kaylin, Levy, here. Y'all working back there? Yes. Find your vertex. I work for it. She, Jason, Jeremiah, Cindy, Jennifer, Angela, here, Rhiannon, Michelle, Osi, Omar, Christian, Diana. Thank you. Samantha, Fatima, Natalie, she's here, Emilio, Javier, Edgar, and thank you, and Cindy.
No, she said change the C6.
B over 2a would be negative. Because negative b is a negative negative 6 is a positive 6 over negative 6. Good. Great. So to find the vertex, you're doing negative b over 2a. Okay, so negative b would be negative negative 6. Would be positive 6. 2 times negative 3. Negative 6 on the bottom. So positive 6, so negative 6 is really close to negative 6. Can you? Good, very good. Okay, I'm gonna give you a few more seconds because I see some people at least started, but then we're gonna get moving. This is good. For this, unargued parentheses, which is at the top, it's not really increasing anymore, or decreasing, it's just like the top.
Let's take this to
Y'all, I'm gonna move one of you. This is August, huh? But every time I look over, you're looking at each other. I'm like, just having a grand old time, which I love the joy, but I need the focus. Did it start doing that same
What, that makes no sense. -1 is
Okay, let me see.
the accuracy.
Overlay.
Oh, you're looking for one. It's 0 and -2 and 0.
Yeah, Catherine. All right, few more seconds. Perfect. Okay, so first, let's kind of like sketch it and then you'll see what I mean. So -1, but then remember you have to take this and plug it in to get the y coordinate. So this is the x coordinate. And then you gotta take that -1 and plug it into the x. Oh, good, perfect. So +6 divided by, and this is -6. Divided by
This was fine. That's why I had
the square, all you're looking at is the number in front. Don't worry about the x's. A, B, and C are just the numbers.
That's all you're at.
You got negative.
Try negative B over 2A. This is A, B, and C. -1, so you got the negative on the bottom and a positive on the top. Right? You didn't change the problem. -6. Sorry. But this is correct. What you did was the other kind of messy. So you can leave it and just like watch the version that no one's going to give it yours because I had to change it. Yeah, that's good. It's more difficult. I just. Alright, y'all, we're gonna bring it back because we can work on this all day long, but we don't have to. Alright, voices off, eyes up here. Perfect, thank you. Okay, so we've got right here a quadratic. Let's recap for a second, starting with the vertex. I saw a lot of people out there doing -b over 2a. Reminder, first, before we get started, today's Friday. Anyone know what Friday is?
Yes.
Raffle day. So I got my tickets. So, I want lots of participation. Today's raffle is one of 3 wonderful prizes behind the colored folders over there. So at the end there will be 3 winners, and if you win, you get to pick a color, any color, and there's some prizes behind there that you can't see and you won't see, but you'll get whatever's behind. So maybe we don't know. I'll never tell you until the end of class. I know you can. Okay, voices off. So I also might give tickets to wonderful people that are listening, and when I say eyes up here, voices off, don't talk to their neighbors. So it could be for just being great as well. Okay, starting off. If we want to find the vertex -b over 2a, I'm going to kind of push us forward a little quicker. Can you raise your hand for a ticket if you can tell me what you ended up getting for that vertex? Yep. -1 as the x coordinate. And then we need to plug that in to get, that's okay, I'll go with someone else to get more tickets out there. We want to plug that in to our equation to get the y coordinate, so we have that high or low point on our graph. Javier, you think you got it? +3 is correct, so our point is -1, 3. And so you can, like if you want, go like this and assume all of these are 1. If you made your own interval, you could do that as well. That is either the top or the bottom of our parabola here, okay? We also learned, which I didn't explicitly ask you for, but in order to graph it, you might need it. We also learned the y-intercept. That was a nice quick one we used to do. Does anyone remember what the y-intercept was? It was either A, B, or C. I'll give you hints so you can get a lot of hands. Anyone remember what the y-intercept was? Yep.
Oh yeah.
C, which in our case is 0, which means the y-intercept is going to cross the y-axis right here at 0. So now we have 2 points on our graph, and we're going to, and I'll still give some participation stamps today, but I'm going to give out raffle tickets too. So I'll try to do all the things, but I might not be able to. So bear with me. If this is our axis of symmetry, and this, it has to go through this point, is our parabola facing down or facing up?
Down.
It's got to be facing down, so just a general sketch. We know it looks something like that, right? Okay. Therefore, that's going to bring us to where our conversation is going to be today, which today we're going to be learning about where things are increasing or decreasing on functions, and we're going to be talking about something called extrema, which is like the maximums and the minimums of our functions. Kind of like the vertex is the maximum of this parabola, right? So let's talk about these two questions. It says, for what values of x are, or is the parabola increasing? So think about your parabola as like a roller coaster ride or something. If you're riding the function on a roller coaster, anyone just in their own words could try to describe to me like where on this roller coaster of the parabola we would maybe be increasing? Just in your own words. Joe, what would you say? Like you can even, like which part of it do you think is, tell me yes or no.
Where the circle, the zero's at?
Uh-huh.
Just don't even know.
Up here? Okay, so, okay, let's see. Other thoughts? I see some other hands. Let's see.
You said the zero? Where the zero
I
at?
said, where is it increasing? If you're riding it like a roller coaster, where do you think your roller coaster would be increasing, Catherine?
By like those negative.
Over here, in this one, on like the negative side over here. Okay, so generally this side, I'm gonna outline it in a different color. Nope, I'm not. Try this one.
Got him.
Yeah, there we go. Do you agree that this is like, you know the roller coaster when they're like, you know what I'm talking about? Any roller coaster people out there? That's like when you're going up the roller coaster. It's really scary. You're going up. That's this part of the roller coaster right here. That's where it's increasing. And it asks for the x values. For what x values are we increasing? We are increasing, no, that was a bad one. Where's the good one? Oh. We're increasing anywhere over here, all of these x values, all of these x values, all of these x values, all the way until our vertex, which is what x value? -1 that you guys solved for. So we're going to say from negative infinity all the way to -1, our values are increasing. Yep.
You don't include -1?
Good question. I did not put a bracket on -1. The reason I didn't do that is because I'm going to argue at -1, when you're at the top of your roller coaster, you're not really increasing anymore. You're like just sitting there before you decrease. So I'm going to use parentheses at minimums and maximums because I can't really say whether it's increasing or decreasing. We're just at the top, or later we're going to be at the bottom. Yep.
Is it okay if we break it?
I want you to put parentheses because of kind of what I just said, unless you can give me some sort of argument. But you can't really say that at -1 you're increasing anymore, right? Because you're at the top. You're not going up. You just stopped at the top, briefly, before you go down. Okay, so based off of that, really quick, about like 30 seconds, I want you to turn and talk to your neighbors about what you could do for decreasing. Where's your roller coaster decreasing right here interval, okay? 30 seconds, see if you can figure that one out before we keep going. Now you can go. Thank All right. That was about 30 seconds. So here we are. I'm going to go with... Oh, Kaylin, thank you for turning your voice off and for listening and being a wonderful student. You get 2 raffle tickets. Terrible students that are still talking. Okay. Edgar.
He's not here. I'll take his spot.
Keep trying. Fatima? Over to you. What was your interval for decreasing? Perfect. Parentheses again, because you can't really say it's decreasing either. And a couple of people have asked me today why this is not negative infinity, because it's like going down. Remember, we're talking about the x values. We're saying starting at -1, forever, the x values, that part of the graph is going down. Yep.
So if it were a parabola opening up from the x up and down, would you do the other way? Or
You're talking about
is that not a, do we not do those?
These guys?
Yeah.
Yeah, why are we not doing these
Is
guys?
that not a, there's not a
Not a,
formula?
not quite.
Not a
Not a function. Because formula. Because it passes through 2 points, right?
Mathematically.
That's good. So it is still a, you can write an equation for something like that, but we're going to be talking again about the land of increasing and decreasing and maximums and minimums on functions, and that's not a function. Okay? Good question. All right, here we go. Moving on. Where's my, there it is. Okay. Quick reminder. Oh, not a reminder, a joke. I hope you appreciate my math joke. This guy, which they're kind of like being mean, but we're just going to go with it. He says, what's his problem? He says, don't mind him. He's just odd. Some of you are like, I'm trying to laugh, but I don't understand. Odd? Why are they saying that he's odd? Because it's an odd function. It has origin symmetry. And these guys are not odd. What are they? Even. Okay. Anyways, quick recap of even and odd. Okay. Quick reminder, problem set 2, you need to bring me on Monday. If you're having issues with that, I told you this is like a weird week, I know. So all you need to do is tell me ahead of time and communicate with me what's going on if you're not going to have it. If not, I'm going to assume that you're going to have problem set 2 from way before Hurricane Harvey ready for me on Monday. And at the end of class, I'm going to go over and like make it really clear, making sure you know like where on the problem set we're stopping. We're not doing the last bit. Yep.
Can you turn it in before the class period? I'm leaving early.
Oh yeah.
So, I mean,
Okay.
If
you, like my bins are here all day long, or like honestly even if you, I don't know, send it with friends that has me in the morning, I don't care. Yeah.
Okay, cool.
I just need it that day at some point by the end of the day.
You can trust
Cool? Yep.
So on this problem set, is there something we can't do?
I'm gonna at the very end make it really clear because I got pictures in here, like what we're doing. Cool? Okay. So let's talk about increasing, decreasing, mathematically, like with more math like notation and symbols. How do we describe whether something's increasing and decreasing? I like the roller coaster because it just makes sense that like when something's going up, it's increasing, when it's going down, it's decreasing. But let's look at these pictures and kind of see if we can write something a little more mathematical to describe a function that's increasing. Okay, I'm going to put up here my kind of definition, but before you write it down, I want you to try to see if you can kind of like engage with me to make sure you understand before you're writing it, because I don't want to write stuff you don't get. So, a function is increasing if, don't write this down yet, but f of x1 is less than f of x2. Let me show you what I mean by that. Those are y values, f of x2, f of x1. See how f of x2 is greater than f of x1? When x1, the x value that went with this one, is less than the x value that went with this one. That means if this x value is behind the second one,
That's slick.
if it's behind x2, then this has to be smaller and this has to be greater if it's going up. Okay? So mathematical notation for like describing increasing. You can write it down now. Don't throw things at people. It's rude. And it's hard to focus when you do that. Yeah. Even if it's a love note. Don't do it. Okay. A function is decreasing if, bring it back, decreasing if for x1 and x2, I'm going to write it this way, there's a couple ways you can say it, but if x1 is still less than x2, then this time the opposite must be true, right? F of x1 has to be bigger than f of x2 if it's going down, right? This first point had to be higher than the second point for it to be going down. So we're going to say f of x1 is greater than f of x2 when x1 is less than x2. Again, this notation, like you're not going to be doing yourself a whole lot, but it's just a way to describe what we mean by something going up or going down, increasing or decreasing. We're all writing it. We're good. We're good. Can you see it? Yeah, perfect. Okay. A function is constant if, constant, like flat, not changing, if when x1 is less than x2, for a point that's behind another one, the y values, or f of x2 and f of x1, are in the same spot. They're equal. Okay? So f of x1 is equal to f of x2 when x1 is less than x2. Fancy way to say increasing, decreasing, or constant. All right. Okay, so when we're going from increasing to decreasing or decreasing to increasing, that's when we get these like hills and valleys and these parts on our graph where we have what we call minimums and maximums. In the past, with parabolas, we just called it a minimum or a maximum. Today we're going to get a little more specific and call something a relative maximum or an absolute maximum and learn what the difference between those is. And then similarly, this got kind of like messed up and written wrong. I don't want to write maximums twice. So relative minimum, sorry, I used the same box and it didn't, I forgot to change it. So we're going to talk about maximums, we're going to talk about minimums. Change that bottom one because they both say maximum. Okay, let's talk about when something is a relative minimum versus when something is an absolute minimum, and when something is a relative max versus an absolute max. So eyes up here. This dot, so you gotta look because you gotta know what dot I'm pointing at. This dot is a relative maximum. This one is an absolute maximum. It is absolutely the maximum point on our graph. Why do you think we're calling this one an absolute maximum? And this one is not an absolute maximum. This is only a relative maximum. Any ideas, Carlos?
Is this higher than the other one?
This is the highest of all high points. Okay? Not only is it higher than the other one, but it's higher than like every other point on that blue line, right? So it's the highest of high. Yep.
You can think about it like as a king and a, like that, right?
Yeah. So this is the absolute highest of highs. This one is relative. It's just like a point along the way where we had the top of a hill. We went from going up to going down. Okay? So we've got relative maximum is anywhere it changes from increasing to decreasing. You're going to get a high point on your interval. And then the absolute maximum is also increasing to decreasing, but it's the highest point on the whole domain, on the whole graph, for any of the x values. Okay. Minimums are going to be similar, relative and absolute. So anyone out there from the crowd, left or right, which one do you think is going to be our absolute minimum versus the relative? The left one or the right one? Yep.
Right.
The right one over here is the absolute lowest of low points, and this one is just a relative minimum, okay? minimums go not from increasing to decreasing, it's going to go from decreasing to increasing. So it's going to be changing from decreasing to increasing to give us a low point. And then the absolute minimum is the lowest of all the low points. Alright. And I got my poster over here. Shows you an example of these orange sections of my graph are increasing, right? The like red pinky sections are decreasing. And then I've got an example of a few like relative max, absolute max, and a relative minimum for you to see. These minimums, maximums, all of these things are what we call extrema. You're going to see that in some instructions in a second. Extrema of the graph, because they're like the extreme points are like up high or down low. Okay? So when I say extrema, I'm talking about minimums and maximums. Notice these are points, right? So this is literally an x, y, like 5, 4. It means over 5 and up 4. An x, y coordinate. So I said maximums and minimums are written as coordinates x, y. Remember in our do first back here, when we said where something was increasing or decreasing, I've noticed some people getting confused because there's like parentheses and a comma, but this is not a point, right? Negative infinity is not like a point. This is an interval from negative infinity to negative 1, and these are both describing x values. Y is like not in here. So I wrote over here, increasing and decreasing are written as intervals. They're not coordinates. It's describing a whole section of the graph. Okay? So something to kind of like keep separate in your brain. Okay, let's try a problem. Example 1. Flip to the top of the next page. This is where your calculators are going to be pretty much used for the rest of class. So if you don't have it, I know we're being flexible because of hurricane and stuff, but you're going to have to do your best to just kind of follow along with us, and you're definitely going to need it on your problem set to complete these problems. So let's take a look. We've got a function. I've got the picture of it here, and we want to find out all of these things. Where is it increasing? Where is it decreasing? Where, if at all, is it constant? And then where are any points of extrema, which is, again, any minimums or maximums. For this one, you need to tell me not only the point, but like what type. Like you'll say relative min and then the point, or absolute min and the point. Okay? So just as some further instructions. For increasing and decreasing, remember these are intervals. For extrema, these are going to be actual coordinate points that we're going to find. On our graph, notice this minimum right here is going to be around negative 3, negative 1, right? But I don't want you to estimate based off of this graph. What we're going to do is actually graph it in our calculator and use a tool to like find where that is. Raise your hand if you've ever used the minimum and maximum tool on your calculator before. Okay, I think I've noticed today a lot of people have. I'm going to show you the steps if not, but a lot of us have probably done this before. Okay? In pre-cal, always, this whole year, we are going to go 3 decimal places. How many? 3, always. So I'm going to make sure first, before we even graph this, so don't go there yet, we're going to stop. We're going to change our setting on our calculator to fix 3 to make sure none of us have like different number of decimals when we're writing our answers in a second. Okay? I'm going to transition over my calculator on here, and I don't, so I'm going to have to pull it up on here, but you guys can keep looking at this. So pull up your calculator. Huh? What is this? Didn't this happen last night? Yep. Okay. One of these days. Okay. So, first thing, let's change our settings. Everyone go to the home screen. Following me. so that everyone can hear, if you could turn your voices off, that would be great. On your home screen, first thing I want you to do is just go to settings over here, number 5, settings. And number 2, document settings. Click on that. The first thing you'll notice, it says display digits. And yours could say a number of things. It might say float something, it might say fix something. We could go into what all those things mean, but for the sake of time today, all I want you to do is go ahead and change it if it's not already at fix 3 to fix 3. And don't press OK yet. Because if you press OK, it's only going to change your documents. Okay? Very important, I want you to press make default because it's going to ask you if you want to change your documents and your scratch pad. And you want both because if you're in scratch pad later, you want it to be 3 digits there too. Okay? So press OK once you press make default, and now your calculator should be operating 3 decimal points, and you're not going to get taken off points for dumb stuff like not having all the decimals you need. Okay? Alright, over to your graph. Woo, graph. If you go to, ignore that from the last class, F1, I want you to go ahead and type in the function. So -1/5 times x minus 1 times, what is it? I don't have it anymore. X plus 2 times x plus 4. If you don't have your calculator, you're looking on with someone or watching me, and you will have to let this to go away. Okay. We here? We see it? In this case, our window looks pretty good. Most of you should probably be able to see the function unless you were on some strange setting. You're going to notice in a second when you guys do one on your own, like part of it, you're only going to be able to see part of it, and you might need to do some things with your window to see it. I don't necessarily just recommend zooming out because then you'll see it gets like really squunched up. You might just want to adjust manually your Y's and your X's, and I can like kind of work with you one-on-one as I'm walking around if you're like, I don't know how to adjust my window, okay? So let's take a look at this one. If this is my minimum and maximum, someone in here who's done it before, how would I actually find those points? Like where can I go on my calculator, Rhiannon?
If you go to menu and then analyze graph and then minimum and maximum.
Perfect. So everyone hit menu, or catch up, menu, analyze graph, and then let's go with min first just for fun. Hit minimum, and you basically click on either side of that low point on the graph. If you don't click enough over, notice I clicked for my lower. If I were to click right here, it's finding the minimum is just the low point on that like part I've selected, which means later if your graph is squunched up and you don't adjust your window and you just don't like click randomly, you might be finding a minimum that's not the one you're looking for. Okay? So be really careful that you're actually clicking now on the right side, the upper bound of your minimum, and then you can click, and here's our little point coordinate for that minimum. Is that a relative minimum or an absolute minimum? Let me go with someone I haven't heard from. I don't think I've heard from you yet. What do you think, relative minimum or absolute minimum?
What?
This point. Is it, we just talked about relative minimum or absolute minimum? 50-50 chance. Which one do you think it is? Is it the lowest point absolutely on the whole graph, or is it just a relative minimum? The lowest point, he says it's an absolute minimum. Other thoughts? Thanks for sharing. Jeremiah? You said absolute as well? Okay, other thoughts? We got 2 absolute.
I thought it was relative because the graph goes down.
Okay, and then she says relative, so we're confused here. So I agree, it's the only minimum that we're gonna like write down, right? And so some people think it's absolute. However, we said that it's the lowest of all points on the graph, not just of all the like dips. Are there other points lower than that point?
Yes.
All these guys are lower, right? And so this is a relative minimum because it's not the lowest point on the whole graph. Okay, so very good. So this is a relative minimum that we just found. I'll bring you your ticket. Let's find our maximum, relative or absolute. Follow up. Relative, good. Maximum, because again, these are higher over here. So let's find our max. Whee! Click over here, click over here, and we got it. Anyone have trouble finding those so far? We good? Okay. Let's record all of this. I'm just going to write it over here because I can't show both at once. First thing it asks for is decreasing, right? Is that right?
Increasing.
Oh, really? First thing it asks for is increasing. Where is it increasing? Our graph is increasing. We'd be going tick, 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 from here to here, right? All the other parts are going down. We're describing an interval of x values. What x value do we start at, and what x value do we stop at? So taking a look here, at this point, what x value are we at? Okay, so we're going to say from negative 3.120, I'm going to use parentheses like I said before. Oh, so you still with me? Still with me? Parentheses, negative 3.120, all the way, raise your hand, until what x value do we stop? Yep?
Negative 0.2.
Good. Negative 0.214 is where we stopped. That looks like a coordinate, x comma y, but it's not. That's x1 comma another x2 down the line. Okay? We didn't even use these for right now. Okay? Okay, decreasing. Maybe a little more challenging because we've got this part and we've got this part, right? So we're going to have two, and when you have two intervals, remember you just put the u in between them? Okay? So for this one, we're going to say from negative infinity all the way to negative 3.120. Questions so far? We're good? U, union.
Negative 3.12.
I heard them say it right here. You got it? Negative 0.214, comma, positive infinity, because then the rest of the graph to infinity goes that way. Okay? Cool? Alright, so that's where it's decreasing. Is it ever constant? No, so for constant, you can just write none. That will definitely happen. There could be times that it's increasing the whole time and not ever decreasing. So you could write none for decreasing, and increasing could be negative infinity to infinity, right? So in this case, we're going to go up and down a lot. We'll see both these, but we might not see constant. Okay, and then last, extrema. Like I mentioned before, I want you to list the different ones. We've got two extrema points. One we said is a relative min, one we said is a relative max. So I want you to write that relative min. You can write REL to abbreviate, but I want you to tell me that it's a relative minimum. And you just need to record this point. So if you don't have your calculator, just have to look at your neighbors if mine's too small up here. 3.120. Good? And relative max. Whew, that's a lot of numbers. That's all on that model problem up at the top of the page. Sorry, my handwriting's really terrible. We okay about that? Okay. Let's try it out. If you go, oops, I'm clicking like my PowerPoint's up here, but it's not. If you go to the next problem down at the bottom, looks like this. I want you to go ahead and graph it on your calculator. Mess with your window if you need to, and if you need help, call me over, and then find all of those things. Okay? I'm going to give you 5 minutes to try to do this, which means you're going to have to be working with a sense of urgency so that we can talk about one more thing before we get out of here. not average rate of change. We're gonna do that on Monday, but you won't obviously be able to do it. So we got one calculator. One, yeah. You're like, oh, we use a calculator.
Oh my god.
Because then if you're doing something like this, it's just like, you're like, just
Stay there, please.
do your calculator. No, yours doesn't work very well. You work with this?
Yes, okay.
Yeah. But you need to do problems. No. I love problems.
But what if you win the round? Win that?
Okay. Yes.
What?
Okay. Let's just go to this settings. Should be the same thing. And you just go to general. And let's change that to fix 3. And then I'm gonna just be safe. Oops, fix 3's done. Okay. And then I'm also gonna go over to where it says graph, because we were in a graph. And let's change that to
Oh my god.
okay. And that should, I believe, be good. Let me see something happening. It shouldn't change any that you've already done, but moving forward it should.
Oh my
But it looks like those are fine.
It's like 2 weeks ago.
How you doing? But can you follow along some?
I know.
Okay. So this one I noticed, kind of see how it's like kind of squinched up because you zoomed out, which you can still totally do it, but I want to make sure you got the right exact point. It's kind of hard to tell whether that's really the bottom. So one thing to do is like notice you don't really need all these X values right here. So instead of zooming out, just change now your X values to
It sounded like
not so far. So let's go just, I think it was probably fine with what it originally had, -10 to 10. You probably just needed your Y's to change. Let's see if that helps us out a little bit, to see it a little better. So now maybe you can see it a little bit more better. And notice your second point, is it actually up there at the top? Oh, okay, then go ahead, then you're
Why doesn't this one go to like
I believe it's, I don't think let me go look at my answer. But if it doesn't go to 3, then it's probably a 0. So you're fine. But what the issue is like if you're on some of the other settings like float, sometimes it's not a 0 and it just rounds it off for you for 2 if there's like tons of them. So you just have to be careful with fix 3, you should be okay. Let me see if that's what I got. Are we okay over here? Got a graph?
oh, I was good.
Let me see. Was that the other one, or was that this one? Oh yeah, this is what you got. For the long. Okay, good. Do you have it? Does it work? Yes. We got a graph. Oh. Do we get a graph? Graph it. Go, go, go. You got 1 minute left on the clock, which means it should definitely be graphed. Should definitely have at least one of them in 5 minutes, if not everything. So you zoomed out, it's now all squunched over here. You're in like the thousands. I bet if you were even at your original, zoom standard,
No, it just starts typing letters out of nowhere.
Are you saying your AC?
the X's were fine, right? You just couldn't see far enough down. So if you zoom out, the problem is it's going to show you all these X's you don't want and it's going to scrunch this up. So really the only thing you want to change in your window settings is you want the Y minimum. You want to see more of the Y down lower. So let's go all the way to like -40 or something just to be safe.
because
Now,
the first time no, I didn't know
I lost it.
I just went Hey,
I'm gonna bring it back.
cover the camera.
No, that's good.
Unless you want it like out.
I'm gonna bring it back right here. Voices off for me. All right, listen up. Okay, here's an example of what it could have looked like graphed, but you'll probably notice, depending on how you were looking at it. Let me turn the little lamp off, sorry. Depending on how you're looking at it, like notice this one's a little bit like scrunched up in the middle. So you can always adjust your X values if you want to kind of like widen it out and you don't want to see as many. So let me really quickly go to Windows Zoom, Windows Settings, and for my X's I'm just going to go from -10 to 10. I think that will be plenty to widen it up. Okay, so it should look something like this. Notice if you click your left and right somewhere else, you're going to get a point obviously somewhere that's not at the minimum or the maximum. So I'm going to really quickly just show you what those 2 points should have been so that anyone that got them can check their work. -1.76, -22.8. And for the max, -0.426, -1.93. If you got something different, I've been seeing that a lot today. Most of the time, that's because when people had the window to where it was really close, they like thought they were clicking on either side, but they were clicking somewhere where their dot ended up like close but not quite there when they were able to like when we zoomed in we were able to see it. So if you got something different, I can kind of check. This is, let's go to Kaylin in the back. Is this a relative min or an absolute min? Good, because it's not the lowest of lows. Sorry. And the other one was also a relative max, I believe. And we can write our intervals right there. I'm not going to write down all those decimals for the sake of time. What I want to leave off with is reminders on your problem set so that then we can do the raffle. So really quickly, eyes up here. On your problem set, listen up so I can let you out on time. Listen up so I can let you out on time. On your problem set, at this point you should now be able to do where it says Extrema. Here you have to type those into your calculator and find where it's increasing or decreasing. Those are intervals. For this one, down at the bottom, you should be able to list all your mins and maxes. Does there necessarily have to be all 4 of these things? It might not have an absolute max. You can write none or leave it. Don't expect to have all 4 of those for both of them. And then last, at the top of the next page, there's a word problem. Don't let it freak you out. It's asking for a max, so you should be able to graph it and find the max, no problem. That means after this point, listen, after this point, after 5, everything else is average rate of change. We have not learned yet. You do not need to complete for Monday. Got it? Anything past that one, you don't need. All right, here we go. First up, if your raffle ticket ends in 239.
Oh wow.
Amelia, which color would you like? Blue. Blue. You get some Takis. Congratulations. Pretty good. Whoa, they're coming in. Okay, next up. 240. 240. Oh, which one?
Yellow.
Which one? Ooh, a small little eraser that looks like ice cream. Congratulations. There you go. Last one. 243.
Wait. Oh, that's me. That's me.
All right, you get a Twix. Oh, it's pretty this side. Okay, it was sitting in the sun right there, so it's kind of melting. A melting Twix.
Hey, I can have it.
Hey, you gotta have to wait and see.